Hello guys, welcome again to Come Your Physics School. This video is about average speed, average velocity, the very basic quantities. For the beginning, I prefer to tell you what the speed is, what the velocity is, and then we can continue by developing those concepts to speed and velocity in average. Look at this man. He's going to have a very short journey to the right, okay? And let's put x-axis here just to see to which direction we can say it is positive or negative and so forth. Moreover, it's easier for me now to measure the distance traveled. Suppose that the man goes to the right for 10 meters and it stops here, okay? The total distance traveled and also the displacement seems to be 10 meters. Okay, forget about that. I need some stopwatch or something to measure the time of this journey. Suppose that I measured that and it's 5 seconds only. I see he has traveled 10 meters in 5 seconds. Okay, if I divide them, I see that 10 over 5 is 2. Means that the man traveled for 2 meters in 1 second. By proportionality also you can find it. Suppose that it traveled for 10 meters in 5 seconds and you ask yourself how many meters, let's say it's d, how many meters for 1 second? You can easily find, yeah, d is going to be 2. So if I just wait for 1 second, this man will go for 2 meters only. Here I can say the speed of this man is 2 meters per second. Okay, 2 meters per second. But what the velocity is, velocity also has a direction because it's a vector quantity, is not scalar. For speed, I need just the magnitude is enough. But when they ask you what the velocity is, you should say, oh, it's 2 meters per second to the right. To the right means the direction. Or you can prefer not to say to right and just put a positive sign here and tell them, okay, if I put the positive sign, it means that the journey is to the right side, to the positive direction of x. And if I put negative sign, it's to the left. Okay? It is not that complicated. Basically, this is the basic understanding of the velocity and the speed. But they are not that easy. Let's continue by a little bit complicated case. Suppose that an object starts from here, from -4, goes to the right, from -4 to 20, and then goes back to x equals 8. The journey partially is to the right and partially to the left. Okay. Now I ask a question. How much is the displacement? You may know or you may have watched my videos. Previously, I talked about the displacement. Displacement is a vector connecting the beginning point and the ending point. So if I connect -4 to 8, regardless of the direction of motion, forget about that. Beginning and the end, okay? I will find a vector to the right, so it's positive because positive direction of x is to the right, by convention in this case. And if I measure the length, the magnitude of this vector is going to be from -4 to 8 is 12. So displacement is 12 meters. Positive 12 means to the right side. If I write it -12, it's going to be to the left side. Okay, then I define the average velocity. The average velocity is going to be the total displacement over the time, the total time of the journey. Journey starts from t equals 0 and ends at t equals 6. So totally 6 seconds. Okay, so it's going to be 12 over 6, 2 meters per second. Positive sign before 2 indicates a direction of motion. So in average, the object has traveled for 2 meters in each second to the right. I know that there are some turning points and so forth, changing direction, everything. Forget about that. I'm just telling you what the average velocity is. So the average velocity is regardless of the turning points, whatever. I can show that the object starts from -4, ends at x equals 8. Finished. 12 meters to the right. Forget about that. Even it could have traveled like this, from -4 directly to 8. Yeah, why not? It will have also the same answer, the same result, provided the journey takes just 6 seconds. That's all. And likewise, the object may go far more to the right and again goes back to 8. If it takes just 6 seconds, I can say, yeah, the average velocity also is again 2 meters per second because the length of the magnitude of the displacement is again 12 to the right and takes 6 seconds only. That's all. But let's have another consideration. Generally, you know that the distance is the length of the trajectory. The object starts from -4, goes to 20. Basically, the length of the journey from -4 to 20 is going to be 24 meters, and then it goes back for 12 meters, you see? 12 meters also here. So totally 24 plus 12, totally the distance traveled will be 36. 36 meters. Forget about direction. There is no direction for distance, you know. Okay? Then I define average speed to be the distance traveled over the total time of the journey. Total time is the same, it's 6 seconds, I know. But upstairs is going to be 36 in this case. It's not 12. So I can write 36 over 6, which is going to be 6 meters per second. But there is a very elegant point. Do we have any direction for distance? No. Do we have any direction for average speed? No. Is the average speed always positive? Yes. Average speed might be sometimes 0 when you don't move, or positive. It can't be negative. It's meaningless. But average velocity, yes, it can be positive and can be negative. I'm all concentrating on one dimensional motion. Don't forget, it's very important. Just one dimension. Let's say it's x-axis. Okay, let's continue. Look at this. So generally, I know that. Look at these two men. The top is a man going to the right, to positive direction, and the bottom is the other man who is going to the left, okay? The top will have positive average velocity and the bottom negative average velocity, okay? Whatever it is, it must be negative. But here, you know that the speed is regardless of the direction. Speed is always positive. So forget about the direction of motion for speed. In speed, just measure the length of the journey, the distance traveled, and divide it by the time. But in velocity, also you should care about the direction of motion. A cyclist travels 16 kilometers in 70 minutes. Calculate in meters per second the average speed of the cyclist. Also, can you determine its average velocity? Okay, let's first consider the first part and then about the average velocity. Here I know that the cyclist has a journey of 16 kilometers. I don't know if it has been to the right, left, I don't know the direction of motion, if it has even any turning point. I'm not aware of that, but I know that the average speed is going to be L, the distance traveled, which is 16 kilometers, in divided by time in 70 minutes, okay? 70 minutes, oh, it's not in second. I need meter per second. Oh, I should convert them. So L is going to be 16 times 10 to 3 meters. And then 70 minutes, 70 times 60, so it's seconds, okay? So it's going to be something like this, okay? 16 times 10 to 3 divided by 70 times 60. Okay, it's 3.8 meters per second. Can you also determine the average velocity? Basically, I see that it travels 16 kilometers in 70 minutes. I don't know to the right, to the left. No. I don't know anything. Even it is possible that the cyclist goes to the right for 8 kilometers and it may go back again to the beginning point for 8 kilometers, and total distance traveled is still 16 kilometers, but there is no displacement, you know. The displacement is 0. Even the displacement could be 0 with, again, 16 kilometers of distance. So, no, I can't say anything about that. Look at this one. Position time graph of a toy car is given. Look at this, guys. It's xt graph. Okay, it starts from 0, from the origin, goes for 2 seconds to the positive direction of x for 10 meters, and then goes back again. So finally, in 4 seconds, the object still is back to the origin, to the beginning point. I think there is no displacement. Okay. Find the average speed and average velocity of the car in 4 seconds. You remember, average speed was L over delta t, which is the total distance traveled over the time. But the average velocity is the delta x over delta t. Delta x is the displacement. You know that there is no displacement. So basically, delta x is 0, so v bar is also 0. Oh, okay. But what about the S bar? Let's take the x-axis on in horizontal direction. It's maybe easier to understand. The object starts from 0, goes to 10. So here, if I visualize the motion, something like that, goes 10 meters to the right and 10 meters back to the left again. You see? It's again back to the origin. So basically 10 meters plus 10 meters, totally L is going to be 20 meters, okay? How many seconds? I see, yeah, 4 seconds. So 20 over 4 is 5. Just 5 meters per second. It's the speed. Can I have any negative speed? No, it's positive always. What about the V bar? V bar is 0, you know. There is no displacement. Finished. Okay, let's continue. Describing average velocity with xt graph. Suppose that in general the xt graph is given like that, okay? I see that the object starts from t1 and x1 on this graph and ends at t2 and x2, okay? You know that mathematically the segment connecting the beginning and the ending point of this curve is called the secant, okay? This is the secant line. The secant line here connects the beginning and the ending point of this curve, okay? And let's establish a triangle here, okay? This triangle is very, very useful. Mathematically, it's very useful. You see, vertically, here I have delta x, which is x2 minus x1. It's exactly the displacement, something we like it a lot, delta x, you see? And on horizontal axis also, I see the delta t, which is t2 minus t1, okay? Exactly from here to here, okay? When you divide delta x by delta t, you know that you have the v bar. So it's very easy to understand that v bar is basically in mathematics the slope of the secant line. So in xt graph, when you draw the secant line, the slope of that, which is delta x over delta t, is something we call it v bar, or the average velocity. Can average velocity be negative? Yes. Guys, look at me, it's very important. Suppose that the xt graph is given like this, okay? Is it negative? Is it exhibiting a negative average velocity? Yes. Because if I draw the secant line, let me draw the secant line by the other color. Yeah, from here to here. This is the secant line. You see? Here the delta x is negative. Yeah. But the delta t, no. Delta t is always positive. So here the v bar is negative. Yes, it can be negative. Pay attention, it's very important. So we have positive slope, negative slope. 3 position time graphs are given below. Okay, A, B, and C. They all start from the origin as I see, and then they get x1 at t1. Okay, which one shows larger average velocity till t1? Okay, larger average velocity. What was the average velocity? You remember, if on xt graph, it was the slope of the secant line. So let's draw the secant line from here to here, and then let's establish a triangle, okay? The secant line is exactly here, yeah. And then this triangle has a delta x on vertical and delta t on horizontal. Do you see any difference between? No, I think they are all the same. They have traveled for delta x, I mean x1, in the time of t1, delta t. Same. So no one has larger average velocity, they are equal. In which xt graph, average speed and average velocity of the object have the same magnitude? Oh, look at this. It's the object A, okay? Xt graph of object A. We should consider A if it has the same magnitude for velocity, average velocity and average speed or no. And then we will consider the B. So let's concentrate on A. You know that S bar, let me write S bar, yeah, it's L over delta T. and the v bar was delta x over delta t. Delta t is the same, okay? Anyway, the object travels for delta t. The only challenge is that L is equal to delta x from the magnitude or no. It's not that complicated. You remember I told you in previous videos that L and delta x have the same magnitude, I mean the distance and displacement, just and only just. The object moves on straight line and has no turning point. It's very important. No turning point. It must go or to the right or go to the left. If it turns back, it's a problem. I see that the object goes to the positive direction of x with different rates, yeah, but finally it gets here. There is no turning point, you know. It starts from here, ends here. No turning point. So yes, here L and delta x have the same magnitude, so S bar and V bar also will have the same magnitude. But on the right side, it's a little bit complicated. I see the object starts from here, goes this big, stops, and then goes back, you know. Finally, destination is here. We have a turning point here because we have a peak point on xt graph. You know that when we have a peak point or a trough like this here, it's a turning point on xt graph. I have explained it in previous videos. So you know that turning point will make different delta x from L. So here I can't say that the displacement and distance have the same magnitude. So S bar and V bar won't have same magnitude. So forget about it. This one has different delta x and different L. Different S bar, different V bar. Okay, let's continue. Look at the xt graph below. Which time interval has larger average velocity? Oh, it's interesting. We have different options, and from t1 to t2 here is one of the options, t2 to t3, t3 to t4, and finally t1 to t4. Okay, I remember I told you average velocity is the slope of the secant line. So let's draw the secant line here, okay? Secant line from t1 to t2. Why not? Yeah, this is the secant line, okay? From t1 to t2. It has a slope, its own slope. Let's go for t2 to t3. t2 to t3, this one. It's a larger slope. So till now, t2 to t3 will have larger slope and larger average velocity. t3 to t4. t3, oh, it's even larger. Till now, this is the maximum. But from t1 to t4, let's make a secant line from t1 to t4. The slope of this gray line is not that large. Among the four secant lines, I think this red one has the largest slope, so I think I will choose this option. Finally, let's consider how speed units are connected. I mean kilometer per hour. You know that it's a commercial unit, mostly used in car speedometers. How is it connected to meters per second? It is not that challenging. 1 kilometer is 1,000 meters. And 1 hour is 60 minutes times 60 seconds. So it's 3,600 seconds. So I plug in the values. 1,000 meters over 3,600 seconds. So it's going to be 1 over 3.6 meters per second. Or vice versa. I can write 1 meter per second is 3.6 kilometer per hour. So let's establish two parallel axes, one for meter per second and the other for the corresponding value of kilometer per hour. Here, let's take 10 meters per second and find how much 10 meters per second will be in kilometers per hour. Okay, I multiply the left side by 10 and also the right side is multiplied by 10 again. So here I will have 10 and the right side 36. That's all. Good, so I got it. For 36 kilometers per hour, I will go for 10 meters per second. So it's very easy to discover the 5. You know that 5 is half of 10, so this is also half of the 36, so it's 18. That's all. What about the 15? Okay, for 15. 1, 2, 3. 3 steps, each 5 meters per second. Here, 1, 2, 3. 3 steps, each 18. 18, 18, and 18. So you should just add 18 by 36, so you will get 54. That's all. So it's very easy to find another more 18 to be 72 kilometers per hour, and then corresponding value in meters per second to be 20. Likewise, 90 and 25 and 30 and 108. That's all. It's not that complicated. You can do it. You don't know how grateful am I to you because of watching this video. Thank you for being with me. Take care. See you in the next video.